Hi, everyone. Welcome to Unfiltered Flow, ELSC. I'm Meghann Cook here with co-host Alan Burdette. And today it is our pleasure to welcome Mr. Gary Goding to the podcast. Gary has been in the fluid power industry for over 41 years. Most recently was president and CEO of Flu US, and now is semi-retired and working special projects manager at Flu. Welcome, Gary.
Thank you, Meghann. Thank you, Alan. Thanks for having me on today.
Yeah, we're happy to have you here.
Yes,
so how did you get started in fluid power, Gary?
Actually, it was actually by mistake. I was training as an electronics engineer, and I'd been through an apprenticeship and university with an electronics company. And part of the apprenticeship was to learn how to compact electronics, so put a lot of electronics into a small space. And this is the days when we didn't have surface mount devices, so everything was analog and everything was big and chunky. But I seemed to excel in compacting circuits and making very large circuits into very small spaces. And finished the university, finished the apprenticeship, and it so happened that one of my colleagues, his brother was the chief engineer of Denison Hydraulics at the time, and he happened to mention to me that they were looking for an electronics person at that time. This is 40 years ago. Electronics in hydraulics industry was very rare. And so I duly went through 7 interviews and ended up getting the job with Denison Hydraulics. It's a company of 1,200 people, and I'm Mr. Electronics. And into the job, we spent a lot of time learning about the hydraulics, which was, I thought, relatively easy for an electronics person. And fell into it that way and instantly loved it. It was something that, you'd learn the electronics part of it, and that was something you couldn't see. Nothing was tangible in electronics apart from the parts you pick up. But electricity, it's ethereal. You can't see it. You just have to measure it and trust it's there. Well, suddenly with hydraulics, I've got fluid. I've got things that are really happening. I can see things happening. I can see things moving. I can feel heat. I can do all this stuff. So very quickly, I discovered and realized that there was motion to be controlled, and that tickled me. So that was me hooked from literally the first week I was there in the company. That and the smell of hydraulics got me as well. The smell of the oil, the noise, there's a particular noise in hydraulics that comes from pumps rotating at 18 or 3,600 RPM. There's a whine, and you get to love that. You get to know it, you get to love it, and you get to recognize it, and you feel comfortable, and all the people around you feel comfortable too. So it's one big happy family. So it was easy. It was easy to get started in that fluid power industry. And again, very welcoming colleagues at that point, and took me under their wing and showed me the rope, showed me what not to touch, what not to open, and how to be safe in and around, working hydraulics. So it was just a very interesting time back in 40 years ago. We were really writing a lot of the rules for hydraulics that we use today. So it was really the Wild West of hydraulics that I joined the company there at that time.
Yeah, I know what you mean about the noise and the smell. Of course, a couple of things you don't like to hear: cavitation and fluid going across reliefs.
Right.
Those are the noises you don't want to hear.
Right.
Well, I don't know. I always enjoy those noises, as the
Well,
ringing
you
and
would.
clanging.
Gary, you've been around over 40 years and worked for a number of companies. What's one of the most interesting projects you ever worked on, or the most enjoyable project you ever worked on? Does one stand out for you?
It does, actually, and it's probably the very first project I ever worked on. And this is again 40 years ago, where we're dealing with electronics that at that time were very large. Everybody remembers the big TVs, the big tube TVs, all the stuff. It was just big. And I joined Denison, and they already had a product under development that when I got there. And the engineering manager showed me this product, showed me this wonderful valve, and he went through how it worked. And it was like a servo valve mechanism. And I got that very quickly because the servo valve's just like a loudspeaker. And I'm a hi-fi geek. I like amplifiers. So I understood very quickly how this servo valve was working with a voice coil and how it would move that jet pipe backwards and forwards. So I got the principle. They said to me, we really need to control this. And here's what we've got. And by the side of this beautiful valve was this enormous controller. It had 3 big electrical cards in it, and it was just big. And the engineering manager said to me, what do you think you can do with that? And I said, well, and remember, I just come from my apprenticeship where my specialist was compacting electronics. So putting, 10 pounds into a 5-pound bag. And I said to just glibly, and this was youth talking back then, right? Just glibly, I said, I reckon I can make it small enough to fit on top of that valve. And he looked at me and he said, really? I said, yes, of course I can. And so that was now my challenge. Okay. And little did I know it at the time, but myself and my colleague who was responsible for the mechanical side of this, who actually is still in the industry today, we were inventing onboard electronics. We had no clue that at that time we were actually pioneering onboard electronics. And we went from idea to prototype, which was shown at one of the Bauma shows in about 6 months. And we were young. We were 21 or something at the time. We just worked all hours God gave us. We worked night and day, weekends. We just were in there having a great time with all the equipment, all the stuff we had. And we built by hand these controllers. We built them so they went on the show. And there it was. We had the first servo valve. It actually was a stroking mechanism, designed as a stroking mechanism off a pump that we turned on its side to make it into a pilot valve. And that then had the electronics bolted on the top, and it was called the master valve out of Denison Hydraulics. And we did an open loop version first, and then we did the closed loop version where we even developed our own LVDT. So that was probably the most important project in my life because it taught me so much. And it taught me so much because there were people that were just constantly saying, you can't do this, and yet we did it. There were people saying, we don't have that, and yet we made it. We designed it. We did it ourselves. And again, it was like the Wild West because there were no rules, regulations. There was no CE marking. There was none of this that you needed at that time. We just knew that walkie-talkies were bad, and we had to make it so that the hydraulics wouldn't wander off and do things if we fired it up near a high power source. So it was just a wonderful learning experience that was very intense for everybody, for myself and for all the mechanical engineers and for the marketing people, because they didn't know how to deal with onboard electronics. They just had no clue how to even approach this and put this into a marketplace. Here we are. So I learned very quickly to not make glib comments and glib promises like that. All right. Because there's a lot of work, but when it works out, you end up with a product that really drives the industry going forward. And so here we are today where electronics is on board virtually everything. Okay. And now we have surface mounts. So now we have smart electronics. Now we have digital electronics. And we'll talk about that a little bit later on. But well, the analog, we had LEDs on it. That was the first thing we'd ever seen in the industry with LEDs on the top. We had battery backup on it because it was a servo valve only using low current. We actually put a Niked battery on the back of it. So if there was a fault, we would switch it off and hold the valve at zero. So we did a whole bunch of things that just weren't in the industry, but I brought with me from the other industry I'd been in, which were common there. And we started to make them common in the fluid power industry as well. So that's probably my biggest achievement and the nicest project that I've worked on ever in my career.
Well, this leads into my next question here. Advancements in smart technology and IoT and how they influence today's machinery. What have you seen?
We've all got, in the fluid power industry, we've all got threats coming at us from electrically driven devices. We're very good at making rotary electric devices. We're getting better at making linear electric devices. But so far, fluid power for linear actuators, we still hold the energy, the way we can transfer energy quickly and effectively. But certainly onboard electronics, sensor technology, we started down this route many years ago when the SAE brought out the J1939 standard. And suddenly we found that in our industry, we were able to piggyback onto the automotive industry, and all of a sudden we had access to data like we'd never known before. And not only data, but all of a sudden we had cheap sensors. We had ways of plugging into and getting information that we'd never had the ability to do before. And so that really drove the explosion of electronics and where we could put them, what we could do with them, and more importantly, how to make informed adjustments to what's going on now. So in the old days, we'd have to write lookup tables where we put in theoretical curves and you'd go up and down these curves, and that would be a best fit solution. Well, now we can in real time adjust something to get the best efficiency, the best operation, the best safety, whatever the best model is you want, we can adjust the electronics now to give you that. That's all in real time. So I think, the advancements are safety, the advancements are real-time adjustments, the advancements are the preventative maintenance. When we start looking at the cost of things these days, obviously the cost has been exponential over the years in our industry, both from the cost of the machinery, the cost of the spares, the cost of doing the work, the cost of maintenance, everything. So if you can do predictive maintenance and save yourself a bundle or schedule it so it falls into the normal schedule maintenance, it's a cost saving and return on investment for everybody. So I think it's really the electronics that we've seen, and I'm biased because I'm an electronics engineer. But I'm also, very cognizant of my mechanical engineering colleagues that that understand and can see the benefits of applying electronics in their industry and feel comfortable doing and can actually see how it's driving people to continue using fluid power parts rather than switching across to clean electrical connectors and clean electrical parts as it is.
Yeah, and that's interesting because that brings up another question, because you've taken the technology from one industry and applied it in a different industry, from electronics to hydraulics. So for professionals looking to stay ahead in the fluid power industry, what skills or areas of knowledge should they focus on to become most successful over the next 5 to 10 years?
Question, and one that I think we as an industry need to really look at how we get people better rounded in their knowledge. And what I mean by that is people have to be aware and not afraid of what's happening in front of them. If you're a fluid power guy or gal who's selling valves or pumps or components that a company makes, don't look at it as a threat, look at it as an opportunity, all right, in front of you. That's easy to say and not so easy to do when you're out there in the field. I get that. But you need to be more rounded. You need to understand what the other people are, what the customer's coming to you and asking you for. And you need to remain relevant in the market, particularly as a salesperson. You need to be able to talk the talk as well as walk the walk to a certain extent. Sure, you can't maybe discuss electronics to an in-depth degree, but you can certainly listen to what's happening, understand, and then take that back to your company and say, okay, this is what they're asking for. We're 70% there with this. How do we get the other 30% to land the order? Or this is what I'm understanding they're needing. That needs to go into our product roadmap. All right. We need people that can recognize the opportunity, can understand the opportunity, take that information back to their companies, either, as I said, to strengthen their pipeline of products, their development, or to understand how they're going to complete that sale and fulfill the solution needed for that customer that's in front of them. The days of going there and selling single products is now, I think, at the very thin end of the wedge. And for those people to remain relevant, they've got to be able to talk about more than just that one product they're walking in the door with. And even if it means them networking to find colleagues who do the other parts, or networking to find ways of pulling a solution together, that's what they've got to start to do rather than just thinking about that one part they're selling. So I think a better roundness, and our NFPA do a wonderful job in the training sessions they offer. They do a wonderful job in the things they can offer through the various colleges. They're doing an awful lot with training young people. And again, we focused on mechanical engineers coming into our business. I think the focus needs to also be equally on the electronics engineers, because we enjoy this too, right? We like getting to it, and it's not all about writing code these days. There are a bunch of people that really like getting their hands dirty. And again, that effectiveness, that satisfaction, that fulfillment of watching a machine work, there's nothing like it. So I think for an engineering person, whether you're electrical or mechanical, we need to pull all those people on board. Today they're called mechatronics, but I still keep hearing there's more of a slant where we need mechanical engineers. No, you need both. All right, and I think that's something that we need to be more aware of.
Yeah, and you're right on two of those points there, Gary. The solution-based selling, absolutely. Independent components anymore, it's an extremely difficult uphill battle to sell.
Yeah, unless it's a very special component, unless it's a unique hydraulic component that you absolutely must have, and it's going to fit in a very niche market. And then we all have them, okay? The people are looking for a general solution, as you said, and that's what I think our salespeople have to get more used to seeing, is being open to what they're seeing, recognize what they're seeing, and bring that data home. Again, to either strengthen their own company or to figure out how they're going to create solutions for the customer and go forward. And again, I don't think there's any harm in finding other people that can help you pull that together.
Well, and this leads to that too. I mean, you've addressed it a little bit here, but what do you see as the, biggest challenges in fluid power?
We touched on it a little bit earlier about the engineering, the pool of engineering that we can draw from. And we still need smart engineering people, because at the end of the day, someone's got to sign off on a bit of paper that says this is how it's going to work, and it's going to work like this, and it's going to be safe. So we still need professionals that will be in there and sign this stuff off and understand exactly what they're happening and be able to crunch all the numbers. I think one of the biggest things that I've noticed over the last few years is, we've got to get more people. I mean, there's a lot of controversy about work from home, work from the office. And I think the best statement I've heard that sums it up is, we don't want to leave people behind, because that's what I see happening. When I see these young people that are wanting to get into the business and they're trying to work from home, I don't think they realize just what the human connection gives them with regards to the levity in the office, for one thing, all right, and communication skills, but also just by osmosis, learning from other people, learning. I mean, my mentors, I learned because I worked by the side of them. We were rubbing elbows together. You know, they would talk to me in whatever tone they needed to get me to understand and listen and let it sink in. And I think that's missing. And I think, you know, while it's great to work from home, because sure, you have the freedom and to do what you need to do, I think there's a huge number of people that should be in an industry that aren't because they feel isolated. And I think we're not going to fill that pool until we figure out some way of making this industry more interesting to a lot more people and making them understand that, you know, coming in isn't a bad thing because, again, you're learning from people that are rolling off the end of this working curve. And, you can be the next bright star, right? Literally. I mean, there's people that can step up and do what they need to do, and they'll be tomorrow's heroes just because they're able to learn what we have today. So,
Right.
yeah, I think it's that pool, that talent pool we need.
Yeah,
Yeah, right there. And to that end, being in the office part, I think, one of the things too, in particular with fluid power, getting your hands dirty. You know, when you're in a manufacturing environment, you're out there,
Yeah.
right? You go stand on a bench and you watch a pumper motor valve being torn down, right? You see the individual components, you watch it being tested, put together, that entire situation. I think that's part of what's missing there too. I think it's very challenging on the engineering side to come into this fluid power realm, hydraulics, and not have that hands-on exposure.
I can agree with you more. I mean, the number of times I would wander around the manufacturing plants, and I've been lucky through my career to work for some just outstanding companies in every way. Dennis and Parker, Eaton and Sun Hydraulics, and then Von Flew. And every one of those companies has manufactured products, and every single one of those companies has made absolute mechanical works of art in whatever I've looked at, whether it's a simple valve or whether it's, a rotating group out of a piston pump, right? It's just been amazing to me how this mechanical stuff goes together and continues to work. And it's just, when you pick these parts up and look at them, the various materials, you're right. You cannot learn about what you're about to sell without looking at one of those things come apart. Otherwise, go and sell a washing machine or go and sell a fridge freezer, because that's as close as you want to get. If you're not interested in getting into the guts of something, maybe it's time to choose something else to do, right? But for me, it was an obvious step. I needed to understand what was going on with the parts I was selling, so that I could talk efficiently, I could talk confidently, I could understand what this thing was doing. And more importantly, when I applied it, in the back of my mind is a mental vision of this thing, how it's working. And if it's not working correctly, why isn't it working correctly? To Alan's point, is it cavitating? Have I got air in it? Am I not driving it correctly? What am I doing that's making that noise come? What am I doing that's not making it move fast enough or far enough? All of these things, but if I didn't understand the mechanical way this thing went together in a basic structure, in a basic way, it would have been harder to put the applications together. So I completely agree with you.
Yeah, I've always thought that if you want to be successful, or you're going to be successful, you got to be curious about how it works.
Curious is a great word, isn't it? Curiosity is, they say it killed the cat. Well, the cat said 9 times at this, right? If he hasn't learned the first 8, then, Darwin kicked in and took care of that. But at the end of the day, yeah, curiosity is it's a great feature to have, and it's one that you should exercise. And you can't exercise unless you go to a manufacturing plant and you see and hear what's going on, meet the people doing it, see the machines that are making stuff happen. It's just a wondrous experience for everybody. And I would absolutely say anybody that comes into our trade, should get some of that. And every company I've worked for has that program in-house where they put newbies in, and you walk around the shop floor. You're down there for a few weeks, few months, whatever it is, but you get to experience that. And by the time you pop out the other end, you fully appreciate what you're about to sell, because you know what goes into making each one of them. So yeah, it's an absolute, in my opinion, it's an absolute that has to happen.
I got a bonus question here.
I have one more
just a couple
question for you, Gary. So what were your biggest hiring challenges? And obviously, based on our conversation here, I have a general idea of what you're going to say. Qualified candidates, retention, time to hire, onboarding. where were your biggest hiring challenges?
So all of the above in a small way, every one of those, there was a slice of all of what you just mentioned in every hire. But I think onboarding was a challenge because we were a smaller branch of a bigger company. So onboarding was always going to be a challenge. And again, because you're a smaller branch of a bigger company, you have to wear a lot of hats, and that worried a lot of people. When we had someone come in and say, hey, this is your prime function, but we really need to help out Joe and Jeff and Cynthia over there. All of a sudden, it's like, why? This is what I'm supposed to be doing. But, you've got to understand, you've got to contribute where we're just a small company, and that's what we have to do. That was very tough for a lot of people to get on. Some people just went to it just like ducks to water. They understood the mission, they understood what we'd asked them, and they just did it. They just got on with it. And in fact, to the point where they would go seek work. Can I help you? I've got some, and those are the kind of people that we loved. We enjoyed that because, again, they were proactive in everything they did. And I think that's probably one of the biggest things that I found is that the younger people, the people we were getting, I can't just say younger people, the people we were suddenly getting in they do their thing and then they'd sit there waiting for the next instruction to come down the pipe, right? Or they'd sit there, done their work, and then you'd find them doing a crossword or something rather than going in and say, hey, can I help someone? So it's hardest. I'm trying to think of how to verbalize that the work ethic, I think, is what we need to think about, is how the three of us here, and I'm just going to say, the three of us here, we're doing this today because we have a work ethic that says we want to help someone, we want to get some information imparted to somebody, and we're not afraid to do that. And we figure out how to do it, and we go ahead and make it happen. I think that's one of the hardest things is getting people to become part of the community and contribute in the company, because they're just not used to doing that. They do just barely enough to cover themselves, and then that, in their opinion, is all they need to do. And so the work ethic probably covers most of what I say would be our biggest problem in today's.
You have just another minute, Gary? I had a question for you as well.
Sure.
Knowing your background and the companies you worked for, I think you can maybe give a good perspective on this. What do you think about the consolidation that's happening in the industry today?
Good question.
It's a good question. And yes, you're right. There are a lot of companies, and this isn't new. We just haven't seen it to such an extent. And one of the reasons it's floating to the top because there are less and less smaller companies around. So all the companies we used to just assume that were out there, all of a sudden you read they've been absorbed and consolidated into a much bigger group. And that's one way, very early on, public companies found they could grow by acquisition, not organically. It's much easier to grow by acquiring an accretive source than it is to go out there and grow organically. So, particularly public companies, and this is the first time I've really worked for a private company, and it's I've got to tell you, it's a completely different feeling, a good feeling working for a private company. But a public company, constantly worried about shareholders, you're constantly worried about publicity, you're constantly worried about the next board meeting and the next shareholders meeting. And sometimes the decisions you make on products or the way you're going in the company aren't necessarily the right ones at the time. But again, my own personal feeling is the public companies, they buy smaller companies to be accretive. That's one way of showing the shareholders value that's going forward. It's a shame because we lose a lot of, we talked earlier today about a particular person that we all know, and he had a great little company going there that was wonderful. And now that's been bought by somebody else, not necessarily absorbed, but we're losing that man's knowledge. He's got a huge amount of knowledge, decades of it, and we've lost it. And we tend to do that. And we also lose brands. As we talked a little bit earlier, we've got some very famous brands that are being bought, are being rebranded. So we don't know what they are. We're losing all that monetary value, if you like, or that huge positive factor that's been built up over the many years by that brand image and that brand name. And that's the negative impact of it. And I think the choice for customers is becoming less. You can't shop apart anymore. You go to one place and where you used to have 3 or 4 places, now you have 1 or 2 maybe if you're lucky. And so your choice is going down for costing. And I think the other thing is your solutions. You've got behemoths in the industry now that are able to turn up and fix solution. That's great for you as a user, not so great for everybody else in the industry because we're getting locked out. And that's a problem for the smaller companies. And that's why a lot of them go for consolidation because they've got no other option. So it's a shame. But, I guess, again, the writing was on the wall. As you get the bigger companies, the behemoths start, they just grow. The 600-pound gorilla in the room, they just keep moving along, and that's what's going to happen eventually. Again, working for a private company, private family company, it's very refreshing, and you get to do things in a company like this that you couldn't do in a public company, which is again very refreshing.
Absolutely. Well, Gary, thank you so much for joining us today. We know you're busy. Appreciate you coming on here and chatting with us.
Very welcome. And again, appreciate being asked. Thank you very much for getting this lined up in front of us. It's been lovely to talk to you both. And again, if you need anything more, don't hesitate to let me know, and we'll get on it and see what we need to do.
Okay. Thanks a lot, Gary.
Very welcome. Thank you, Meghann. Thank you, Alan. Have a great day. Take care. Bye-bye now.
You too.
Bye.